All right, buckle up, everybody, because today we are launching a deep dive into the moon. You guys sent in a ton of slides, and honestly, I'm already geeking out.
It's amazing, isn't it? Just how much we still don't know about the moon. It's practically right next door, cosmically speaking.
Right, it really makes you wonder what else is out there. So today, we're going to tackle everything from its surface to how it formed. Oh, and we can't forget those iconic moon landings,
Those are always a crowd pleaser.
for sure. But let's start with the basics. How did the moon even get there in the first place?
Well, one theory is called the capture theory. Basically, the idea is that the moon formed somewhere else in the solar system and then at some point got snagged by Earth's gravity, like a cosmic magnet.
So it was just wandering through space and got pulled in. Sounds a little too simple, doesn't it?
Yeah, there are some holes in that theory. Like, if the moon formed somewhere else, why is it so similar to Earth in terms of what it's made of?
Yeah, that's a good point. Okay, so what are some other ideas?
Well, there's the fission theory. This one says that early Earth was spinning so fast that a chunk just kind of flew off and became the moon.
Like a figure skater flinging off a glove. Except, on a planetary scale.
Exactly. But
Oh.
the physics of it don't really add up.
Okay, so we've got the capture theory and the fission theory, both with some problems. What else is there?
Well, this is where it gets really interesting. It's called the giant impact theory. Imagine early Earth, still molten and hot, getting slammed by this Mars-sized object. We call it Theia.
Okay, I'm picturing it. This is going to be good.
It would have been an absolutely colossal impact. Debris would have been blasted out into space, a massive cloud of it.
Wow. So what happened to all that debris?
Well, over millions of years, it slowly started to clump together, and eventually it formed the moon. It's like the ultimate cosmic recycling project.
The giant impact theory, that's the one where a Mars-sized object called Theia smashed into Earth, flinging debris that formed the moon, right? Sounds pretty wild.
It does, but there's actually a lot of evidence to support it.
Like what?
Well, for one, the moon rocks that we've brought back are surprisingly similar to Earth's mantle.
You're kidding.
Right.
So if it had formed somewhere else entirely, we'd expect the moon to be made of totally different stuff.
Exactly. And there's more. Both Earth and the moon have these big iron cores. That lends more weight to the impact theory, too.
Okay, I'm starting to see why this is the leading theory. Anything else?
Oh, yeah. The moon's orbit is tilted compared to Earth's, which wouldn't make much sense unless something dramatic happened, like a giant impact.
So it really does seem like the giant impact theory is the winner. Case closed. Now let's move on to what the moon is actually made of. It's surprisingly similar to Earth, but with some key differences, right?
Right. One big difference is that the moon has much less iron than Earth, and a lot less water, too.
That makes sense if you think
Uh.
about it. I mean, that massive impact probably vaporized a lot of that stuff.
Hmm.
But what about the stuff that is there? What's the moon's recipe, so to speak?
Well, the lunar crust, the outermost layer, is mostly made up of oxygen, silicon, aluminum, calcium, iron, and magnesium. Sound familiar?
Those are some of the most common elements on Earth, too, right?
Exactly. And the mantle, which is the layer beneath the crust, is also similar to Earth's mantle, but with a little bit more iron and magnesium.
Okay, crust and mantle, check. Now, what about the core? What's hiding in the center of the moon?
The core is smaller than Earth's and mostly made of solid iron.
So, similar ingredients to Earth, but in different proportions, which again kind of points back to that epic collision. It's amazing how that single event shaped so much of what we see today.
It really is.
Speaking of amazing things to see, let's talk about those lunar phases. You know how the moon seems to change shape in the sky throughout the month? It's like a celestial magic trick.
Not magic, but it is pretty cool. Remember, the moon doesn't produce its own light. It reflects sunlight. As the moon goes around Earth, the angle at which the sunlight hits its surface changes, so the illuminated part we see grows and shrinks. So that's why we see everything from a sliver of a new moon to the full disk of a full moon. And it all happens in this predictable cycle, too. That's why we can predict those cool events like lunar eclipses.
Exactly. And people have been observing and tracking these lunar cycles for centuries.
It's like having a front row seat to a cosmic dance. Okay, I'm ready to zoom in even closer now. Let's explore the lunar surface. What can we find there?
Well, picture a world that's completely different from our own, covered in craters, towering mountains, deep valleys, and vast flat plains.
Let's start with those craters. They're like scars from ancient asteroid impacts, right? Some of them are hundreds of kilometers across. It's kind of a reminder that space can be a pretty rough place.
It definitely is. It's a testament to the moon's long and dramatic history.
And then there are those dark, smooth plains called Maria. Maria meaning seas in Latin, right? But they aren't actually seas, are they? Nope, not at all. These maria were formed by ancient volcanic eruptions. Imagine molten lava flowing across the lunar surface, filling in these vast depressions. That's how those dark, smooth plains were born.
Ah, so that explains why they look so different from the lighter, rugged highlands. Those are like the moon's ancient, weathered face, right?
Exactly. The highlands are heavily cratered and haven't been resurfaced by volcanic activity, so they offer a glimpse into the moon's earliest history.
Okay, we've got craters, Maria, and highlands. Is there anything else we should know about this lunar landscape?
Well, there are also these things called lunar rills. They're long, narrow depressions that look like channels or trenches.
Lunar rills, huh? Those sound interesting. How do they form?
Well, we're not entirely sure. Some scientists think they're collapsed lava tubes, like underground tunnels where lava once flowed. Others believe they might be evidence of ancient tectonic activity, like miniature versions of Earth's fault lines.
So even those seemingly simple features can tell us a lot about the moon's complex history.
Absolutely. Every crater, every rill, every mountain range is a clue waiting to be deciphered.
I like that. Okay, speaking of exploring the moon's surface, let's talk about the most daring exploration of all, the Apollo missions. Back in 1969, when Neil Armstrong and Buzz Aldrin made history with Apollo 11.
It was a monumental achievement for humanity, landing in the Sea of Tranquility, planting the American flag.
And who could forget those words as Armstrong stepped onto the lunar surface? One small step for man, one giant leap for mankind. Gives me chills just thinking about it.
They collected lunar samples, did experiments, and brought back all this data that just revolutionized our understanding of the moon.
And we can't forget about the other Apollo missions that followed either, each one building on the last and adding to our knowledge. It's a legacy of exploration that continues to inspire us today.
Absolutely.
But here's the thing. The moon's importance goes way beyond those historic landings. It plays a crucial role in life here on Earth, like a silent guardian watching over us.
That's right. It's much more than just a pretty sight in the night sky. For instance, did you know that the moon's gravity actually helps stabilize Earth's axial tilt?
Hold on. Really? How does that work?
Well, it's all about gravity. The moon's gravity acts like this gentle hand on Earth's shoulder, keeping its rotation steady. Without the moon, Earth's tilt would wobble much more, and it would change a lot over time.
And then that would mess with our seasons, right?
Exactly. If Earth's tilt changed wildly, certain regions could experience these extreme temperature swings, making it almost impossible for life to adapt. You might have scorching summers followed by winters that last for decades.
Okay, yeah, that does not sound good. So the moon is like our climate control system, keeping things relatively stable here on Earth.
Like having a cosmic gyroscope, keeping our planet from spinning out of control.
That is pretty mind-blowing when you think about it. We tend to think of Earth as this isolated planet, but it's really part of a delicate dance with the moon, and the sun too.
It really is a beautiful symphony of celestial forces. And the moon's influence doesn't stop there either. It even affects the length of our days.
Wait, what? How is that even possible?
It's all about a cosmic tug-of-war. Over very, very long periods, the moon's gravity is actually slowing down Earth's rotation.
So our days are getting longer.
Very, very slowly, yes. Millions of years ago, a day on Earth was only about 22 hours long.
Wow. So does that mean that eventually Earth will stop spinning altogether?
It's highly unlikely. The process is super gradual, and other factors are at play too. But it does highlight the moon's long-term impact on our planet.
It's like this silent force shaping Earth in all these subtle but profound ways. It really makes you appreciate our lunar neighbor, doesn't it?
It really does.
Okay, well, after this deep dive, I don't think I'll ever look at the moon the same way again. But we're not done yet. There's still so much more to discover about our lunar neighbor. Stay tuned. So we've been talking about all the amazing ways the moon affects us here on Earth. But what about the moon itself? Like, what's going on beneath its surface? Is it just, a big solid rock, or is there something more happening down there?
That's a great question, and honestly one that scientists are still trying to figure out. We know the moon isn't geologically active like Earth. It doesn't have volcanoes erupting or this tectonic plates shifting around.
So it's basically a dead world then, like a cosmic ghost town.
Well, not quite. I mean, there's no evidence of any major geological activity, but there are some subtle hints that that things aren't completely quiet beneath the surface.
Okay, I'm intrigued. Give me the scoop. What kind of hints are we talking about?
Well, for one thing, scientists have detected what we call moonquakes.
Moonquakes.
Yeah.
So the moon is actually shaking a little bit.
Exactly. They're these seismic events, sort of like mini earthquakes. They were picked up by instruments left on the moon by the Apollo missions.
Moonquakes? Wow, so they're not as powerful as earthquakes here, right?
No, they're not as powerful or as frequent as earthquakes on Earth, but they do suggest that there's some movement happening deep within the lunar interior.
I wonder what could be causing them. Maybe there's some residual heat left over from the moon's formation. Or maybe tidal forces from Earth are kind of squeezing and stretching its interior, causing some friction.
Those are definitely some of the leading theories. And then there's this whole other mystery. Lunar swirls.
Lunar swirls. Now you've really got my attention. What are those?
They're these strange, bright patterns on the lunar surface that, well, they kind of look like swirls of paint. And get this, they're often associated with magnetic anomalies.
Magnetic anomalies. Okay, now things are getting really mysterious.
Right. Scientists still aren't entirely sure how they form, but one idea is that they're connected to interactions between the solar wind and the moon's ancient magnetic field.
Hold on. Solar wind?
Yeah. It's this constant stream of charged particles coming from the sun.
Oh, right. Okay. But you're saying the moon might have had a magnetic field in the past? I thought it didn't have one now.
You're right. The moon doesn't have a global magnetic field like Earth does today, but scientists think it might have had one billions of years ago. And these lunar swirls could be like these ghostly remnants of that ancient magnetism somehow preserved on the surface.
Wow, so it's like a magnetic time capsule. So we've got moonquakes, magnetic swirls, and either clues that the moon might be hiding something beneath that dusty exterior.
Well, this next one is a real game changer. Scientists have found evidence of water ice at the lunar poles.
Wait, what? Water ice on the moon? I thought it was completely dry.
For a long time, scientists thought so too. But in recent years, observations have confirmed the presence of water ice tucked away in these permanently shadowed craters at the moon's poles.
Permanently shadowed craters.
Yeah. These craters are so deep and cold that sunlight never actually reaches them. They're like these perfect little freezers where ice can survive for billions of years.
That's incredible. But how did the ice get there in the first place? Did comets crash into the moon and, leave behind their icy cargo?
That's one possibility. Another is that water molecules from the solar wind might have interacted with the lunar surface and formed ice.
So we might have the sun to thank for lunar ice. That's pretty amazing. And this discovery, it has huge implications for future moon missions, right?
Oh, absolutely. The presence of water ice could be a complete game changer for lunar exploration, and maybe even for living on the moon someday.
Okay, tell me more. How could we use this lunar ice?
Well, think about it. Water is essential for human survival.
Right.
We need it for drinking, growing food, and even just basic hygiene.
Right.
But right now, we would have to ship all of that water from Earth to the moon.
Yeah, it's not like we can just order a pizza delivery to the moon.
Exactly. But if we can extract water ice from the moon, it would make setting up a long-term base or even a colony much more feasible.
It's like finding a hidden oasis in the middle of the desert.
Exactly.
So what else could we use the ice for?
Well, we could break it down into its basic components, hydrogen and oxygen. Hydrogen can be used as fuel, and oxygen, obviously, is essential for breathing.
So instead of hauling all those heavy tanks of fuel and oxygen from Earth, we could just create them right there on the moon.
Precisely. It opens up a whole new world of possibilities for exploring and even living on the moon.
This is getting me really excited about the future of space travel.
Uh,
Okay, but before we get carried away with, dreams of lunar cities, let's bring it back down to Earth, literally. You mentioned earlier that the moon plays this key role in stabilizing Earth's axial tilt. Can you break that down for me? How does that actually work?
It all comes down to gravity. The moon's gravitational pull acts like a gentle hand on Earth's shoulder, keeping its rotation steady. Without the moon, Earth's tilt would be much more wobbly. It would change dramatically over time.
And that wobbling would mess with our seasons, right?
Exactly. Imagine if Earth's tilt shifted wildly. Some regions could experience extreme temperature swings, making it nearly impossible for life to adapt. Scorching summers followed by winters that last for decades.
That sounds pretty chaotic. So the moon is like our climate control system, keeping things relatively stable here on Earth.
You got it. It's like having a cosmic gyroscope, keeping our planet from spinning out of control.
It really is incredible to think about how interconnected everything is in our solar system. We tend to think of Earth as this isolated planet, but we're really part of this delicate dance with the moon and the sun.
A beautiful symphony of celestial forces. And the moon's influence goes even further. Did you know it actually affects the length of our days?
Wait, seriously, how's that even possible?
It's all about this cosmic tug of war I was talking about. Over very, very long periods, the moon's gravity is actually slowing down Earth's rotation.
You're telling me our days are getting longer.
Very slowly, yes. Millions of years ago, a day on Earth was only about 22 hours long.
Wow. So does this mean that eventually Earth will just stop spinning altogether?
It's highly unlikely. The process is incredibly gradual, and there are other factors involved too. But it does highlight just how impactful the moon is to our planet over the long term.
It's like this silent force shaping Earth in subtle but really profound ways. The moon is truly a remarkable companion.
And that's just scratching the surface of what we know. There's still so much more to learn about our celestial neighbor.
Well, speaking of the future, let's shift our focus to what lies ahead. What are the next steps in lunar exploration? What can we expect from future missions to the moon? We've uncovered so much about the moon already, its formation, its composition, even those hidden ice reserves. But what about the future of lunar exploration? What's next for humanity's journey to the moon?
That's where things get really exciting. We're kind of on the cusp of a whole new era of lunar exploration, with countries and private companies all over the world setting their sights on our celestial neighbor.
So it sounds like a new space race is heating up.
You could say that, but this time it's less about, competition and more about collaboration and scientific discovery. It's like the whole world is coming together to unlock the moon's secrets.
I love that. So what are some of the big missions on the horizon? What should we be looking out for?
Well, NASA's Artemis program is a major player. Their goal is to establish a sustainable presence on the moon.
Sustainable presence. So we're talking about more than just a quick visit, planting a flag and taking some pictures.
Exactly. Artemis is about building a lasting infrastructure, for scientific research, for utilizing lunar resources, and maybe even for space tourism someday.
Wait, lunar tourism. Are you telling me that people might actually be able to vacation on the moon in the future?
It might sound like science fiction, but it's becoming more and more realistic. Companies like SpaceX and Blue Origin are developing reusable spacecraft that could make traveling to the moon more affordable and accessible. Imagine hopping on a rocket for a week-long lunar getaway.
That would be incredible. Talk about an out-of-this-world experience. But aside from tourism, what kind of science will Artemis be focusing on?
Well, the program has a wide range of scientific objectives. They'll be studying the moon's geology, its ancient magnetic field, the composition of that lunar ice we talked about. Oh, and even searching for signs of past or present life.
Hold on, did you say signs of life on the moon?
It's a long shot, but it's a possibility scientists want to investigate. If life did exist on the moon, it would most likely be in the form of, tiny microbial extremophiles. Organisms that can survive in really harsh conditions.
So those permanently shadowed craters with the ice, they could be harboring microscopic alien life forms. That's mind-blowing.
It's a fascinating thought. And even if we don't find life itself, studying the moon's environment could give us clues about how life might have arisen elsewhere in the universe.
So the moon is like this giant laboratory for understanding our place in the cosmos.
Precisely. And there's more. The moon is also a prime location for astronomical observations.
Because it has no atmosphere to distort our view of the stars.
Exactly. Imagine building telescopes on the far side of the moon, shielded from all the light and radio noise coming from Earth. We could see deeper into space than ever before and potentially make groundbreaking discoveries.
So we could detect signals from distant galaxies, or maybe even other civilizations.
It's definitely within the realm of possibility. The moon could become our gateway to the universe, a platform for unraveling its greatest mysteries.
This is all so incredible, but let's be realistic for a moment. These missions are incredibly complex and expensive. What are some of the challenges and risks involved?
Well, you're right. There are definitely challenges. The lunar environment is incredibly harsh. There's extreme temperature variation, exposure to radiation, and the constant threat of micrometeoroids. Those tiny space rocks zipping around at high speeds.
And we can't forget about the logistical hurdles of transporting people and equipment to the moon and back. It's a massive undertaking.
Absolutely. It requires international cooperation, cutting-edge technology, and an unwavering commitment to safety, but the potential rewards are enormous.
So the risks are high, but the payoff could be even higher.
Exactly. Expanding our presence beyond Earth has the potential to lead to scientific breakthroughs that could change our understanding of the universe. It could inspire future generations of scientists, engineers, and explorers, and it could ultimately push the boundaries of human knowledge and capability.
It feels like we're on the verge of a new chapter in human history, and the moon is at the center of it all.
And it's important to remember that the moon isn't just a scientific frontier, it's also a source of wonder and inspiration for all of humanity.
Absolutely. Every time I look up at the moon, I'm reminded of how much there is left to explore and how much we have yet to learn.
So the next time you gaze up at the night sky, remember that the moon isn't just a celestial object. It's a symbol of our collective curiosity, our ambition, and our potential to achieve truly extraordinary things.
What a perfect note to end on. This deep dive has been an incredible journey. We've explored the moon's origins, its surface, its impact on our lives, and the exciting future of lunar exploration. It's been a privilege to learn alongside you.
The pleasure was all mine.
And to all of you listening out there, we hope this has sparked your own lunar fascination. Keep looking up, keep asking questions, and who knows, maybe someday you'll be one of the pioneers setting foot on the moon.
Until then, keep exploring the universe, one deep dive at a time.